Hi everyone, great to be here today. So that's me, I'm Harold. I'm associate professor here at the School of Computing. And I'm joined with my colleagues Angela and Suranga, who are sitting over there. And we're going to share a little bit about some of the experiences that you might have as a student at the School of Computing. So I lead this lab called the Collaborative Learning and Adaptive Robots, or CLEAR lab, at the National University of Singapore. And what research area that we're interested in is embodied AI. So you might be interested in what embodied AI is. And you might have seen that over the past few years, this is a video that I took in London a couple of years ago now, showing the different kinds of robots that exist in the world. And we have one such robot here today. This is Coco, which is a robot in our lab. So Coco, wake up. Okay, so hi Coco. Hi. So people want to see Coco do some tricks? Yeah? Sounds right? Okay, so Coco, can you do us a trick? Can you show us something that you can do? Okay, so Coco can do some tricks. That's pretty nice. So that looks very impressive. But I have a bit of a confession to make, okay? Coco seems intelligent, but actually it's not. So the real intelligence is, where is Atava? He's sitting over there. Okay, that's Atava, who's controlling the robot, okay, via remote control, what we call teleoperation. Now, what we do within embodied AI is to try to give Coco intelligence of his own. So we combine artificial intelligence with robotics in order to enable physical entities, such as robots or even handheld devices, in order to help us with tasks in the physical world. All right, you can think of it a different way, which is that we're going to give AI a body so that it can help us with tasks. And many companies and people are seeing this as a natural evolution of AI. So this is from NVIDIA, where they highlight that we have moved from perception to generative AI now, that we've probably paid with, to agentic AI now. We're in this transition. And the next step is towards physical or embodied AI. So if this is interesting to you and you want to know more, you might be curious about, how do I get started in this field of embodied AI? What do I need to know? So we've distilled it down to 3 major things that you kind of need to do. All right, the first is to get a good fundamental understanding of what AI is. And then you need to get your hands a little bit dirty. You need to do science, you need to test hypotheses, you need to build AI models, you need to build AI programs. And finally, you need to build systems. So deploy these AI models onto physical devices so that you understand the entire stack, going from perception and sensing all the way to decision making and control. And this gives you a deep understanding of these embodied AI systems. So at the School of Computing, we help you in order to explore these 3 different areas. For the fundamentals, we give you a good grounding in AI via our courses, and then you can participate in the different labs via our research programs, either through Europe or the final year project FYP. All right. And what I'm going to do in the next few minutes is to give you examples of these 3 things to make the experience a little bit more concrete for you. And then Angela and Suranga are going to give you even more examples to help you to understand the experiences that you might have at the School of Computing. So let me kick off with the fundamentals. And you might have used one of these tools before. These are image generation tools where you can provide a prompt, for example, NUS Open Day Week Socket, and then the AI goes and thinks for a while, you'll see it in a second, in order to generate you an image. All right, so after it thinks, and it generates this image. So anyone notice something a bit wrong with this image? So AI is imperfect. You might notice that that's not socket, right? If you know socket, socket's white. That's not socket. So I can correct the AI by providing a prompt, and then AI corrects an image, and that's socket, that right there. All right. Okay, so you might be interested in how these models work. And if you look around, ask ChatGPT, or you ask Google, right, you're going to find out that these models are essentially what we call diffusion models. And if you Google a little bit more, you'll find a paper like this, where it describes this model in a deep technical way. So you see it starts out with some very nice images, which are all AI generated. And then it moves to the next page, and it shows you this funky little diagram. And then if you go a little bit more, then you start to see a wall of math. All right. At this point, if you were like me, when I started off my undergraduate degree, you feel a little bit confused. Okay, what is going on? I don't really understand what this is all about. how do I go from here? It seems very hard. So at SLC, what we try to do is to guide you through the process so that you can develop this understanding that you can actually make sense of this paper. So this is one of my classes. This is 3264. These are all my amazing students. And in this class, what we do is we guide you through understanding this sort of deep technical content. We start you off by understanding the fundamentals of machine learning, what is overfitting, what are losses. We move on to trying to translate these course ideas into something which is very crisp. And we've often used mathematics to do this because it's a very crisp language. And we finally move on to advanced models such as diffusion models. Now, it's very hard for me to condense like one semester's worth of class into 30 seconds, but I'm going to try to do that by giving you an idea of how these AI models generate an image. All right, this is called a diffusion model. So let's just say we want to generate socket, an image of socket. And how they usually used to do it in AI is that you would try to get AI to one-shot generate this from a blank image or from random noise. Okay, you have something that doesn't look like anything. You tell AI, please make this into an image of socket. All right, and unfortunately, this is too hard. Okay, for a long time, we failed to do this effectively. And what is nice, neat idea in denoising models is to simplify the problem. All right, instead of trying to generate in one shot, we just train AI to clean the image slightly. And we repeat this cleaning process many times in order to generate the image. All right, and this is a much, much easier process. And this idea, this insight comes from understanding the structure of the problem and then leveraging knowledge of that structure in order to come up with an elegant solution. And you see this motif across AI as well as computer science in general. So now that you understand a little bit about diffusion models, what has this got to do with embodied AI? Well, they don't seem connected. Let's talk a little bit about science and a Europe project associated with that. So these diffusion models don't only need to generate images, you can also use them to generate robot motions. It's what we call policies. So we can generate these out using the similar kinds of models. Here you see some examples from different labs around the world, and we do this kind of work at the School of Computing as well. So this is Swanran. Swanran joined us as part of his Europe program. He joined us as part of this research where we were looking at training these kinds of diffusion models to enable robots to perform tasks. And here what we realized was actually training the models to do this in one shot also is very difficult, okay, even with this multi-step process. And we looked at the problem and noticed that for a lot of tasks, what is important is learning the underlying skills. So for example, if I want to pick up something, I would reach above it, close my fingers and pick it up. If I want to open a drawer, I would reach ahead, close my hands and pull it. So this reaching up, closing my fingers, these are basic skills. And if we train the model to do these basic skills and then combine them in a clever way, we can train the model much more quickly. All right, and that's what Swanran did. And by the end of his Europe, we was able to get the robots to do something like this. So this is in simulation where the robot is performing complex skills by combining these underlying basic skills together. So this is an example putting burger, fries on a tray, putting an object into a cabinet. And this is an example of doing this on a real robot. And getting the algorithm to work on a real robot is really much more challenging than just getting it working in simulation itself. This work was recently accepted to ICLR. ICLR is a gathering of the world's leading AI and machine learning scientists. This year it will be happening in Brazil. And I think this is a fantastic achievement for someone in the third year of their undergraduate studies. So I talked about science. Maybe let's move on to systems. And I want to talk about a particular final year project or FYP that you can do in your final year of your thesis. And there are these three guys, okay, up on the screen. There's Suso and Tiwan and the guy and is Jiaming, who is one of my PhD students. And three of these guys decided to participate in a worldwide competition called the Earth Rover Challenge. And what they would do is to get an AI model to navigate one of these robots, okay, in different cities. So you see here, this is India. You see other cities as well in the video. And this is a very challenging task because all the different countries are a little bit different. They have different weather conditions. They have different people behavior. And you have to get the robot to navigate across multiple waypoints, okay, to a particular target objective. So the team participated in this, and they came out first place, all right, among different universities around the world. You notice that we are 6 there. Why? Because the first 5 are all human players. So we're still behind the humans on this task. Nevertheless, we are the top AI team. So how did they do this? Well, the secret sauce lies in, again, understanding the structure of the problem and then finding an elegant solution. So here they found that the most difficult part is really for the robot to understand where is it safe to go. And so they built an AI model in order to make this prediction. So they started off by looking at the image and then getting the AI model to recognize that, okay, certain areas are safe, certain areas are not safe. And once you understand the traversability or the safe regions, you can then plan a path to get you to your goal. So this is an example. You remember Asava from before, who controlled the robot. Now he implemented this system on our robot dog. So instead of him having to control it everywhere, the robot now can move on its own to get from point A to point B. So here the robot is on the top left, looking at the area, seeing where it's safe to go, and then trying to navigate safely into the region on the bottom right. Right, just gonna make a roundabout, U-turn, and go out. Point out that the robot here has no map of the environment, so it's as if seeing this place was a brand new setting. Okay, so that's on the system stage. So I've given you a good, I hope, highlight of 3 different things that you explore at the School of Computing. I would like to do a shout out, a thank you to all the people, including Athalva, who make up the lab. And there's a good reason why I'm still here in the School of Computing after 9 years, is because of the wonderful people and the wonderful colleagues that I have. So if you want to find out more about lab, you can check out this QR code, take a picture, or you can scan it, and they'll bring you to my lab website. We will find out more about these different projects that we have beyond what I could talk about here today. Okay. All right, you've been a great audience. Thank you very much. Let me hand you over now to Angela, who will follow up more about the science of these systems.
Hi, everybody. My name is Angela Yao, and I'm an associate professor at SOC also. I work primarily in computer vision. And today I want to showcase some of the research that we are doing in our group from this idea, centered on this idea of seeing, which is what computer vision does, towards helping, which I think will lead very nicely into Suranga's talk later. So we're looking at this path from action recognition towards visual AI assistance. So let me give you a bit of self-introduction before we start. This is my 17-year-old self, so probably around the same age as you guys, now contemplating what to study. I grew up in Canada, specifically in a place called Edmonton. And Edmonton is one of the northernmost cities, so it's pretty cold there. We have winter about 5 months of the year. It gets as cold as -40. So when I had the opportunity to go somewhere warmer like Singapore, I thought, hey, that would be great. And I think my spark for AI, it hit in around second-year university. And I think this is the same stage that we want to incorporate our students very early on towards hands-on work. And so in my second-year university, I built a line-following robot. So we designed this robot to follow lines on the floor. Now, I don't have a photo of the actual robot, so this is Gemini's imagined version of the robot. I think mine didn't look as pretty. Didn't follow lines quite as well either. But for me, that's when the spark hit, was really assembling all of these electronic components together, putting it together, and then seeing this physical building construction actually respond to my code and to my programming and so on. So that's where I decided, hey, this is really cool. This is what I want to do. So today I want to talk to you about our work on video understanding. And video is pretty much anything, any sort of visual capture over time. And you find it actually everywhere in all sorts of devices. The most obvious is on our phones, but also in all sorts of platforms like robots and autonomous vehicles. And more recently, we're looking to see and put video inside of our smart glasses as well. And in my group, we look at video understanding, and our main focus is actually understanding people, trying to figure out what people are doing within this video. And our main focus actually recently is to look at egocentric video. So what we mean by egocentric video is looking at video that's captured from cameras that we are wearing on our bodies, and we imagine these to be embedded into future devices that we might wear, for instance, our glasses. And one of the most important things that you might see actually from such video is our hands and what we're doing with our hands. And so we really want to focus on the various actions that we might perform with our hands. In this example of someone who's cooking, They're cutting the eggplant. But what's tricky is actually the objects that we're manipulating, that we're moving around, they change in appearance even though as we perform different actions. So in this case, we start out with the whole eggplant. The eggplant looks in one way, but then as we cut it up, slice it, and then dice it, it starts to look very different. And so our strategy is to track the hands and also track the objects that we're dealing with, and then look at how they change over this course of the action. And looking at these changes is what helps us distinguish these very fine-grained differences between the various types of cutting actions, whether it's slicing or dicing in the example that I gave. Sometimes we might even use the hand poses. So the poses are the various joints that you see colored in orange and green. So we also develop algorithms to estimate what the hand poses are. We might use these hand poses to support our understanding of the various actions. And doing so actually is really nice because we can estimate these hand poses very efficiently. And so that way we can also measure them perhaps even from wearable sensors, for instance, on our wrist. And so then this helps us keep our hardware devices very light and efficient and have a smaller battery and last longer throughout the day. So in this example here, I'm showing somebody who's assembling a toy, and we'll come back to this toy assembly a little bit later on. If we pair this type of computer vision algorithms, understanding the various actions a person is doing, together with the latest LLMs, we can actually create an assistant to help us through various procedures. So in this case, we have an assistant. You can imagine if this was embedded in my glasses now, helping me do something. Maybe you've never made coffee before with this mocha pot. It can guide you step by step to tell you, well, here you should put in the coffee filter, then you add the coffee in, screw the top on, and so on. So assistance is great. Following these steps is really great. But for us in the real world, as a person who's following these instructions, maybe we don't always do it correctly, right? So in this case here, you can see this person is assembling this toy. We can tell actually they've missed the seat before they try to put the top of the car on. And for any human, they can see this, so that won't work. So they need to put in the seat before they assemble it. And so for the various steps, wouldn't it be great if our AI assistant can recognize that there's a mistake about to be made? And one thing I want to emphasize here is actually this attaching of the cabin. That's not wrong in and of itself. It's only wrong because of the order that we do things, right? So this is a bit like putting your shoes on, and then afterwards you realize, actually, I forgot my socks, right? So we would like our AI assistants to tell us when we're making these kinds of mistakes and warn us. And how do we do this? We follow the stream of the various actions, and we keep track. And we can see here that based on the context of the previous actions that have gone on, then we realize this is a mistake in the first time. Then the AI system can tell us so, then we make our correction, and you can see again the cabin, the second time we do it, is actually correct, whereas the first time it was wrong. So detecting mistakes is great, but wouldn't it be great if our AI systems can even warn us and anticipate what it is that we need before it actually even happens? And this is this idea of linking, trying to estimate human intentions now, and then linking these intentions to the various objects. So you can say, you know what, I want to go out now. I want to gather all of my things together, my phone. What should I use? And the AI assistant already knows. Well, my goal is I'm leaving. I might not say my objects specifically. It might recommend you that you want this bag. What's the tricky part is that our AI assistants tends to latch on to the objects that we see in the scene instead of what it is that we need. A bit like your recommender systems telling you, after you've searched for your various products, it keeps recommending you the same products that you've already bought before. In this case, I can only see the bag in the scene or the phone, then it will recommend the phone, even though your intention is going out. So the right answer actually really depends on the context as well as connecting it to your various intentions as well. And if we shift towards applications that we think will really help the greater stretch of society as well, we're shifting towards assistance applications. In this example, you can imagine, what if our AI assistant can help us in terms of in terms of accessibility, right? So for the blind and visually impaired, they might ask, what is this that I'm looking at? Is this the entrance to the bank? Are there obstacles in my way? And is it safe to cross the road? And I think Suranga will talk much more about the concept of accessibility for AI as well. So this is what we're building towards to AI assistants. We want to put all of this together into systems. One, as a daily intelligent assistant to help us and walk us through hands-on tasks, maybe of things that we've never done before, we're not so familiar with. And also in terms of a visual companion to support, for instance, the elderly or the visually impaired as we go out in our everyday lives. So I would like to use this last slide to acknowledge all of the students, some of them who started in as bachelor students, so like yourselves, in my group, and I would like to invite you to join us on this journey. Okay. And with that, I'd like to hand over to Suranga, who will talk more about the hardware.
Hi, good afternoon, everyone. My name is Suranga. I'm an associate professor with the School of Computing, as well as I'm the Vice Dean for Communication. Just now you heard two talks from my colleagues, Angela and Harold. Some of the foundational, some amazing hardcore stuff, right? They build new models, they generate data sets. I say I'm a consumer of AI, and I'm in the category of AI plus X, where we try to use AI to solve domain-specific problems. In my case, I look at how to use AI to assist people, assistive technologies, which I call assistive augmentations. The reason for me to do this is I was undergrad here in the NUS 26 years ago. And when I was living in the KE7 hall, I heard this sound. So I went out and checked who's by the door, and it just so happens that there was no one. And back then, there was a messenger service called Yahoo Messenger, and this was the notification sound. I was really embarrassed that I'm doing a degree here and I don't even know this simple thing. And it was so demoralizing that at one point I thought I was not good enough to do this degree. But when I sat down and thought about it, what am I supposed to do when you hear a knocking sound? Am I supposed to look at the screen, or am I supposed to check the door? So I actually did what a human with a good sense would do. So I thought technology is not designed properly. It's my chance to learn the basics and one day change the technology to fit us than us having to learn how the technology works. So there's three driving forces behind my research. First thing is I say all of us are disabled one way or the other. It may be a permanent disability that you can't see things, so basic things gets harder. It may be a situational thing where you are in a country that you don't know the language and just buying a simple product becomes hard. Or it could be you're in a group that you don't understand each other's culture, background, so you can't fit in. The second problem is a lot of these digital interactions are different from the way we behave as humans. For example, if I need to give this clicker to Harold, I'll just take it and pass, right? Because it's tangible, I can hold it. If I need to pass a digital thing, say a photo from my phone to another person's, especially back in the days, it was very hard. You need to email or use a USB drive, all kinds of things that doesn't feel as natural as just passing something. So we looked at how do we give this tangibility to intangible things. Here I see a phone number. I take it as if it's tangible, drop it to my phone, it gets copied, or obviously the transfer happens to the cloud, but the point is you interact in a very natural way. Eventually this led to a product of Samsung called Samsung Flow that allows you to seamlessly move across devices, which is downloaded over 50 million times. The third problem is a lot of these digital devices are disconnecting us from real world. They're actually designed to catch your attention, and more attention they get, sometimes better for them, for their business model. And this disconnects from us, right? Imagine I get a call now, I take my phone out, look at who's calling, I'm disconnected. And we think these devices are part of our lives, but they're actually not. You can do a simple experiment where I try to get the phone out and open the app and browse through without looking. it's very difficult because you don't have the coordination. Whereas if I ask you to touch your forehead, touch your earlobe, touch your nose, you can do it instantaneously because we had that built-in capacity which we call the proprioception. So why don't we leverage that to input things to digital devices so that we don't have to disconnect from the world. So we took ear as an example, asked a bunch of people to come to the lab and touch different parts and see how accurately they could do. Ear as a 3-button input doesn't seem to be a bad idea. So we prototype, build a version, and you can imagine now suddenly if I get a call, I can just cancel the call. If I'm jogging, I can change the music, change the tracks, just without having to take my attention away. So these are leading to this idea we have in the lab, which we call assistive augmentation. So this is an idea where we think of technology not as a separate tool, but as an integration of our body, mind, behavior. The idea is to move away from thinking, how do we build things, the system user compatibility, saying that, hey, I use this tool to do that, versus I actually did it. Seamless integrating to what we do. And that's the idea of assistive augmentation. We have done a number of projects over the years, but for the purpose of this talk, I'll just take one of those examples, which is IC. The latest version I'm wearing, I'll come to that. The motivation for this was from a simple observation. When I did my postdoc, there was a blind friend who took the same class with me. The way he accessed lecture notes was he would take the phone, unlock the screen, browse to an app, open the app, take a picture, and the phone will read out the notes to him. For him, that was great. He was very happy. But for me, I was like, why does he have to do so many things to get a simple thing done? Why can't he interact naturally like how we do? So that led us to interact with a lot of people over the years, do lots of user studies and understand. We took the camera out of the phone, put them in various places, index finger, wrist, lanyard, smart glasses, smart headphones, experimented. How can we build this very natural, seamless experience for them? Before the whole LLM era, this is the version we had, which was a headphone with a camera, microphone and a speaker, which sees what's in front of you, and then you click the trigger ring, it answers you one question. So this is an example from Singapore Fair Price.
Big beans, am I right?
Yeah, correct.
Fair pies, big beans.
Let's try this.
Okay. Chocolate chips. Pancake mix.
Yeah. So this was one trigger, one question. And suddenly, come 2021, all the GPTs came up, and suddenly we can change this to a very powerful companion. Now I can engage in a conversation. There's something that sees what's in front of me. These large language models allows me to do visual Q&A. So now you can go into a very effortless interaction. I can say, hey, I see what's in front of me, and then it tells me what's in front of me. If I'm interested to know more, I can ask it to tell more, or I want to know what specific brand is, what specific flavor, all these things you can do as much as having a sighted companion with you. So essentially what we built is this layer of visual intelligence leveraging the great stuff that people like Angela does, where the front end could be something like this, which is the optimal hands-free, screen-free version, but it can also run on a phone, although it's suboptimal. It can run on all this amazing hardware that other all these industry players are building. And in the middle layer, we have a system that learn and adapt to the user, remember things, and then respond in natural language. And obviously, you can build so many different assistive applications. Now, as I said, you can build this visual Q&A system for blind people to extract information. You can build things such as, even simple things like, hey, what's the weather today? Then you can do a, simple tool calling, search the web and get the weather info. You can say, remember, I met you, I remember this person. Next time I see you, it can remind me, this is the person, you met before. We are working on some specific projects with, for example, with Grab. Now there's a voice-enabled version, which allows the blind person to book a taxi through voice, and then the IC will know when the taxi is coming. When it's nearby, it goes to a video scanning mode, start reading number plate, and then tell you, okay, your taxi is here. And then lastly, you can also make specific sites more accessible. You can load in the site specific information and then provide IC as a guide that knows the site. Another example is one of the biggest challenge for blind people here in Singapore is taking public transportation. In that context, sending an image to the cloud and waiting for it to tell you what it is doesn't work because this is time critical. So you can also run small models on board that gives you real-time information. So there's a lot of possibilities. And also the hardware. We opened up the hardware. Essentially what I'm wearing is an Android phone built as a form factor of a headphone. So if you can build Android app, you can build anything on this, and we open up this for people to build their own IC applications, and it's up to your imagination. And while these are nice, cool applications, there's a lot more to it, a lot more impact these things lead to. One of them is really taking this out to the world, and NUS provide great opportunities. One example is the NUS GRIP program that allows the students and researchers to bring this out through university spin-offs. And from this very early stage prototype, few years later, we have a product now, which has been spun out as a NUS startup, supported by NUS GRIP as well as the Singapore Focal Agency for Assistive Tech, SG Enable. And what it does is now the focus is to make these beautiful sites enabling and inclusive for everyone. To my first point, regardless of whether you're blind or sighted, you go to these places, you are blind to the information. You don't know the stories behind what's in the gardens, by the way, what's in the botanical garden. Everyone is blind to that information. What IC now does is it allows you to see these hidden information, hidden stories, tells you the things, and you can tell, hey, I'm interested in these things. It is your personalized guide to tell the stories and give you a personalized, curated experience. And we are the first UNESCO site, the botanical gardens, that will have IC up and running, which allows anyone to go and experience the garden independently. And this is an example from our own NUS museum, our Natural History Museum, where we took a blind person. Before, she said, oh, for me, this is an aircon room, nothing else. Suddenly, that empty aircon room became experiential through IC.
Hey, IC, what's in front of me?
You are standing in front of an enormous diplodocid sauropod fossil.
Using ICs actually brings me a lot of convenience. I go to many museums, for example, but they meant nothing to me. After using IC, I realized that I can get more involved with the items, having a better understanding of what the object is about without even needing a guide with me.
This is not just general GPT output. We work with the sites and input the site specific input to train our RAG model, so that what you hear is what you might heard from a guide, experienced guide who knows about that specific site. Yeah, so that's one example, but we have been doing so many different things, and a lot of students have been working with me, and we build their capacity, train them to go on and do stuff. We disseminate our information through research papers and create commercial impact through pushing them out as startups. And sometimes, you set up these projects as, things to create social impact. There's a lot of people behind this in the Augmented Human Lab, including lots of students who do these things as part of their undergraduate research project, as part of their final year projects, as part of their PhDs, and they do this stuff. And I can safely say that given who I was 26 years ago and the training I got from NUS to someone who didn't even know how a Yahoo Messenger works, to someone now change how people interact with technology, you guys have amazing potential. My invitation is join us, we will train you, and then you will go on to do great stuff that will change the way we live, work, play. Thank you. So now we have some time. I invite my colleagues Angela and Harold. If you have questions, please feel free to Either you can ask them through the mic, or you can submit through the QR code. Either way is fine.
I have a Slido here. So,
Okay, sure.
so you can put your questions onto the Slido by scanning that QR code, and I can see the questions on my mobile phone.
Either way is fine.
Yep.
There will be mics around
Mics
as
around.
well.
Yep. If you have questions, you can go straight to the mics. People are often shy.
Okay.
Oh, okay.
Still.
For those who have questions, you just have to raise your hands and we'll bring the mic to you.
This one in front. One question up front. Yeah.
Hi, good morning. Still now means it's a really insightful means whatever you give to us actually through this session. So I have only one question, that for any of the 6 computer science program, so it is going to be the accessible for this lab, or it's a separate part of the program that is you are going to introduce here.
If I understand the question correctly, what you're asking is,
Uh.
if a student does one of these
Yeah.
programs, can they work with Harold, Angela, me, and many of
Yeah.
the similar faculty members?
Yeah.
I think all these programs, undergraduate research programs, FIPs, we take students from all degrees, right? If you are part of SOC, you get the chance to work with not just 3 of us, any of our faculty members through various programs.
Okay. Thank you very much.
Let me check whether. Okay. There's a question online. How does studying in NUS Computing prepare me for the AI future you guys have painted? What courses should I take? Well, depends on what you're interested in. There are the AI fundamental courses. For example, the class I teach, 3264, which is Foundations in Machine Learning. That's a fundamental course that I think everyone interested in AI should take. And you will be required to take if you take a bachelor's in AI. And there's also Foundations in AI, which teaches you about planning and decision making, which is also very important. Then once you go beyond that, you can take courses, for example, that Angela teaches. And
So you can do more specialized courses in perception and sensing. So for instance, I teach computer vision. So this is one of the ways of sensing, but we also have courses on audio, as well as hardware and
Right.
robotics as well.
And one more thing, we are also wanting to make sure that you get access to some of the latest tools as well as work on real problems. For example, just recently we made an announcement that we started a partnership with OpenAI that opens up all their tools for you to work with. Plus, they will bring real world problems. And that's one example. We have a partnership with Google. We have a partnership with IBM. So not only you teach, you get to learn fundamentals from our faculty. You also get the chance to work with the most advanced tools and the key players of the industry. So you are well aware and ready to go out.
are there jobs of this nature when I graduate?
Oh, I'll take that. As you know, MOE does their the graduate employment survey. Right? I mean, data is hardcore evidence. So the one that came out last Thursday, if you look at it, all our programs, not just the AI program, all our computing programs are the most employable, most paid compared to all other computing programs from any other university in Singapore. So that's a hard fact. What will happen in 5 years? We don't know. But I think if you are interested in computing, learning that at NUS is your best shot, I would say.
So I'll add on to that a little bit. Within the context of embodied AI, so looking at combination of artificial intelligence and robotics, we see a lot more activity in industry now. There are a lot of startups in Singapore. For example, I just visited a couple of them last week. They're starting up in the Block 71 Fusionopolis area as well as regions beyond. Suranga has a startup. I have a startup looking into space of embodied and physical AI. So I think that jobs will be present, especially if you look at this frontier of forward-looking technologies. So there's a question online. I'll read it. Does this count as a dissertation mod? If yes, does a student that takes this is he exempted or she exempted from the 3/6 month internships?
As far as I know, you can further clarify this with our admissions office. As far as I know, you can do the internship, and finally a project is now a choice, not something compulsory. The internship part, I think, as far as I know, most programs it's a requirement. Whether it's a 3 months, 6 months, those are options. And I invite you to go to our admissions webpage. All these are listed down, black and white, very clear.
Next question. How do you find the inspiration to kickstart a project? I find it tough brainstorming ideas when there have already been such products being developed.
You want to take? I can take that.
You want?
I think the top line, if you say, oh, there's somebody working on the blind work, assistive tech for blind, and I shouldn't do, I don't think that's the way to go. There's a lot of things. The devil in the details and nuance. And for me, the way I would choose project is part of that is the knowledge. The other part is paying attention, which nowadays a lot of people don't do. So there's a leverage for those who pay attention. Even the IC was by paying attention. And there's two ways to do this. One is you pay attention, you recognize a problem, and you try to solve. That's the outside in approach. There's also, when you come up with things that never has seen the world, which is the inside out approach, where you can see, hey, what if I did this? That will open up so many things. I would take both. In my particular case, I'm more of outside in person, where we observe something and try to come up with a solution and verify that indeed we solve the problem. Some of a very small percentage of my projects are some very, our internal curiosity, and then we put it out there and see what goes with that. So for me, that's how I approach.
Right. So I think I have something similar where it's either problem-centric or curiosity-driven. So very often I have a particular problem that I'm interested to solve. And the questioner was saying that, some products already exist. But very often the product doesn't quite suit me. It doesn't quite suit what I need. And it might have limitations that I would like to resolve. And so in going deep, one level deeper is often important when it comes to brainstorming. Execution is very important, and sometimes people discount how important execution is towards deriving a product that is successful. The second is curiosity-driven, which is not really looking at a particular product, but is I'm interested in this area. Why don't I just take a look at it? And sometimes when I'm looking around the area, I come up with new ideas, and I do this with my students, and then we go from there, right? And you refine that idea further, ask questions, and try to develop that idea into something more concrete that then we can either instantiate as a program, a software, an AI, or a device.
Any more questions?
Oh, okay. I think we have time for one last question. I'll read this one. Is the hardware or software side harder to pick up? If someone who is interested in robotics but is deciding between mechanical engineering or computer science?
I think there's different challenges in both. Both are difficult, both are easy in that sense. I think it has more to do with one's interests and personality rather than anything.
And I'll add a personal story. I think all these are my experience, right? When I started as undergrad, forget about hardware, software. I never spoke English. And I'd go to lecture theater, record the thing, bring back to my hostel, listen to that, transcribe English to my own language. But it's a matter of your passion, how much hard work you're willing to put in. And it also a temporal effect. You do something for a day, you won't change, right? I mean, if you go to gym, you don't see the shape in a day or two, right? You have to do prolong. So I did that 4 years. I was okay. I graduated with first class, kept on doing, got the PhD from NUS. So yeah, it took time. It takes time, but if you have the passion, if you are willing to commit, I think I would say go for it. You can do.
Yeah. So I completely agree. It's all about your personal inclination as well as your interest. And I would encourage you to pursue those things. And you'll find down the road, you're going to see ideas from these two areas merge together, especially if you're interested in the context of embodied AI and in AI and robotics. Okay, so I think that's all the time we have for today. Thank you very much, and we hope to see you at the MPH area. And take care, everybody.
Thank you.